listening to Neurosalience, the OHBM podcast.
Welcome to the OHBM Neurosalience podcast. I am your host, Peter Bandettini. Here we discuss with brain mapping scientists cutting-edge findings, initiatives, controversies, and tools, and try to put it all in perspective. In this episode, I discuss all things consciousness with Dr. Melanie Boly, an assistant professor in neurology at the University of Wisconsin-Madison. In this wide-ranging conversation, we discuss clinical applications of consciousness assessment, sleep, a model of consciousness known as the integrated information theory, and much more. Enjoy. Welcome to OHBM Neurosalience podcast. This is a podcast that highlights people, issues, interesting findings in the field of brain mapping. And today we have our guest is Dr. Melanie Boly. She's a neurologist and neuroscientist who's worked more than 15 years or more than that in the field of altered states of consciousness, such as vegetative state, sleep, and anesthesia. She's worked with and has been mentored by such people as Stephen Lories, Adrian Owen, Marcello Massimini, and Carl Friston. Her research is directed at combining neuroimaging techniques such as PET, fMRI, TMS, EEG, and high-density EEG, and potentially simultaneous EEG and fMRI to a theoretical framework known as the integrated information theory of consciousness, which we'll get into a little bit in the podcast. She hopes to uncover the neural mechanisms associated with the level of consciousness, as well as its contents in healthy subjects and neurologic patients. So she's both a clinician and a researcher. She has over 150 publications and an impressive H-index of 77, and is associate editor of journals such as Neuroimage, Frontiers in Consciousness Research, Frontiers in Brain Imaging Methods, and Neuroscience of Consciousness. Currently, she's an assistant professor at the University of Wisconsin in the neurology department with a secondary appointment in psychology. She received her MD in 2005 and her PhD in 2009, both from the University of Liège, Belgium. And from 2009 to 14, she did postdocs at the University of Liège and University of College London, and also the University of Wisconsin-Madison. And so by all measures, Dr. Boly is a rising star in advancing our understanding of the neural correlates of altered states of consciousness. She also collaborates with many luminaries in the consciousness research field, including Christoph Koch and Julia Tononi, who's also at Madison. So welcome, Melanie, and it's great to have you on this podcast. So before we get into all the questions.
Thank you so much for the kind introduction, Peter.
My pleasure. Yeah, so before we get into all the questions, I usually like to start out by understanding, by just getting a sense of how you got started, how you actually, everyone has an interesting sort of perspective on what made them interested in the brain itself and also in consciousness. And so were there any events in your life that were significant as far as that's concerned?
I have to say, I think it's thanks to my parents, my education. They were quite strict. I grew up in the Belgian countryside. And in my summertime, for example, I had not much to do because they wanted us to basically stay in the nature and not play video games or things. And then I started actually to look a lot because there was not much to do outside, to look inside, and got interested in reading about dreams, daydreaming, and the mind. And then I thought, I hesitated to do psychology versus medicine, but I thought in medicine, there was a lot of things about the body that were known. And so I decided to become an MD. And then from there, also same reason, in neurology, there was much more, I thought, kind of building block of knowledge than psychiatry. That was my opinion. Then I decided to become a neurologist. But then doing so, I also saw that there was so much to learn about looking inside the brain, not only, the behavior, but also looking inside the brain with neuroimaging. And so I approached people in Liège, like Pierre Maquin and Stephen Lories, to try to work with them. And I was super lucky to be actually able to be trained by both Pierre Marquet and Stephen Loris, because they had very complementary point of views, working on dreams, working on sleep, working on coma. And so that's kind of how I got started. And then doing my PhD, I compared basically sleep, anesthesia, and coma, and tried to find some general principles on like what would make someone conscious versus not. And then tried to look more at the big picture. I thought that not only doing experiments, but combining experiments and theory was very important in order to find the next best questions to ask. In a way, you have so many possible things you can do. And then that's why I moved also to Madison, Wisconsin, to work with Giulio Tononi on integrated information theory, and just combining clinical work and seeing patients. I call neurology the battlefield for consciousness. You see so many different cases that you couldn't even imagine,
Yeah.
And then combining that with normal subject research, I think this is a fantastic, and then the theory aspect to it. So there's both research in normal consciousness and then in patients, and then combining that with theory. So that's kind of what I chose to do. Yeah.
Okay. All right. Yeah, no, it's interesting how you're sort of combining, neurology. I mean, so there's a couple of interesting things. One is, it still seems to me like the whole field of understanding altered states of consciousness is just barely even beginning, even though it's been going on for a while. It's maybe picking up momentum. And I think a lot of that, as you suggest, has something to do with sort of the influence of neurology on that. And seems, trying to understanding the physical biologic correlates of these altered states. But of course it has impact on psychiatry as well. And so it's nice. It seems that the best work comes from combining those two areas.
Right. And neurology, at least like the coma question, this is a great place also to start. I was very lucky to be able to work with Stephen and Adrian Owen on that, because there's really huge ethical implications to try to diagnose if someone is conscious or not. For example, for withdrawal of care, this is life and death decision. If someone is conscious, you would not withdraw care. If someone is not conscious, then you might discuss it, right? But so there's a huge ethical implication in trying to figure out if someone is conscious or not. But then it also raises a lot of issues. For example, we know behavior is not enough, because you can be unresponsive, say, for example, during sleep, you can be unresponsive and have experiences. And like when I started, I thought this might not apply to coma patients, but then with Adrian Owen, we did the imagine playing tennis experiments, and we saw that actually a lot of patients in vegetative state, 15 to 20% of them, they don't do anything at the bedside behaviorally, but they're able to imagine playing tennis when you ask with fMRI. So that was a big lesson to pushing the field to realize that behavior is not enough, and you need to try to find some other solutions for it. Yeah.
Yeah. Yeah.
Because the ethical question is really about subjective experience. Is there someone behind the stare?
Right.
This is the question you want to address. And there are lots of interesting questions that come on how can you actually do that? Yeah.
Yeah, especially if they're unresponsive and actually, we'll probably talk a little bit more about the tools, using either TMS or like the experiment with Adrian Owen, in which you sort of try to talk to the subjects and have them listen. The question that this pops in my mind, I'm just jumping ahead of myself, but the trying to find a neural correlate of sort of consciousness, so that you continue to try to bring them out of their coma, as opposed to assuming that they're brain dead or whatever. Have you ever had patients who by all objective measures were not conscious, who were somehow able to then, you certainly don't want to, there's been many cases like, with Terry Schiavo or whatever, where it's a hard decision. But have there ever been situations where even it shows that there's no evidence for consciousness, but there's still brain metabolism, and they eventually recover, and then they somehow spontaneously start to have, or is it once they've passed this threshold, there's no going back?
So there are different issues there, like mixed in one. One is the patients in coma, brain damage patients that are unresponsive. sometimes you can find some positive evidence of consciousness when you test them better, like complex behaviors, response to command, right? If you don't have that, then you have to accept that you don't know because you don't have enough data.
Yeah.
Then what kind of other data can you get? If you have no behavioral science, then you could try to turn to neuroimaging. And then, you know, some very complex cognitive acts like imagine playing tennis, everybody would accept that you cannot do that unconsciously, but then there is a gray zone where you need to validate your markers against subjective reports. So you need to actually, you know, look at the neural correlates of consciousness outside of coma, try to understand consciousness in the brain. And then from there, you can try to use this to infer if someone is conscious, likely to be conscious or not, right?
Yeah.
So the science of coma, the diagnosis of, you know, coma beyond response to command by fMRI, if you want to actually interpret residual brain activity as evidence for consciousness being preserved or not, you actually need to look at the big picture of the NCC, the neural correlates of consciousness, to understand this. Yeah.
Okay.
And so that's basically, and yes, there are some reports of delayed recovery in coma, which is another complementary question. So if you want to understand like when a patient could recover or not, it's also useful and I would say necessary to understand the links between consciousness and the brain, what kind of networks are necessary, you know, what kind of dynamics are necessary, and then you might actually improve both prognosis and treatments.
Yeah.
This is what we're also discussing in the Curing Coma campaign. I'm the lead of the subgroup on the science work group on mechanisms, and that's what we argue, that you actually need to look at not only brain function in coma, but the other states too, in order to get the big picture of consciousness in the brain. Because in coma, you have to accept that you don't know.
Yeah.
If you don't have positive evidence, you're uncertain, and you need the rest of the data on the brain and consciousness to figure this out. Yeah.
Yes. Yeah. And right. And it definitely does seem that there's you know, growing array of tools for trying to assess this. I remember reading, you know, using like for instance, TMS and looking at the EEG response, the complexity of the response. And
right. So one important thing to realize when we want to get a marker for consciousness is explicitly it has to be validated against subjective reports, because that's what we want to know. Is there someone experiencing? So you need to validate it in someone who can tell you, yes, I was conscious, or no, I wasn't conscious. Like I was not there, I was there during sleep or anesthesia, right? That's what we did with TMS.
Yeah.
But also you have to look at not only wakefulness versus sleep, dreamless sleep, you also need to challenge it in states where people are unresponsive, like REM sleep or ketamine. You really need to, in that sense, it's a dissociation between consciousness and responsiveness. You need to validate your markers, knowing, that's what I was saying, it's kind of similar to neuroimaging, where you try to see what is specific for consciousness versus something that goes with it, but is not the same responsive. Because at the end, what you want to know is that person who's unresponsive, is there an experience, you know, is there someone experiencing, having subjective experience behind this unresponsive state, right? So and that's what we did with Marcello Massimini, was validating that marker of perturbational complexity, which was actually derived from some hypothesis from IIT on what kind of brain, you know, causal interactions would be actually required for a cerebral network to support consciousness. But
Okay.
But it is validated in other states, then we infer from it. When it's validated in anesthesia and sleep, then we go to coma and we say, okay, so what do we find? But we didn't validate it in coma per se. See what I mean? It's a very important one, because actually you don't know, and you have to accept you don't know.
Yes. Yeah. No, I see the whole process, and then each one is a state of validation. Yeah. Right. Okay. Yeah, no, it's so we'll probably get into a little bit more of that discussion a little bit later, but just to begin, just to take a step back really quickly, your work first caught my own attention back in 2007, and just to briefly talk about this paper, because it's intriguing, and it seems to have a lot of suggestions, but and I'm wondering how, you know, the field has gone on from this or not. But so basically your 2007 PNAS paper showing how resting state fluctuations, specifically, where were they? Basically lateral frontal parietal cortex and the thalamus. The fluctuations themselves seem to predict when a subject could detect some stimulus at threshold, and which was the first, actually, sort of ahead of its time in many regards, it's showing that that resting state was dynamic and it actually modulated, on that time scale, sort of your attentional threshold. I mean, people look at attention changes over the course of longer time periods, but seems like there's this constant fluctuation, and that's even a conscious state in that regard too. I mean, you can have many different conscious states, and you're constantly from moment to moment changing conscious states. So right. I don't know, do you want to maybe briefly describe that paper and maybe talk about its implications or any work you took further from that?
So that paper came out of some observations that when I was analyzing the data we were collecting about laser stimulation. I was trying to correlate brain activity to the intensity of the stimulus, and that was not really yielding a lot of results. But then if I was actually looking at what subjects report, then I had much better correspondence between brain activity and my marker. But then also I saw huge fluctuations within session and between subjects about what they were perceiving. So then the hypothesis was that maybe these fluctuations, there might be some difference in baseline brain activity that would trigger them. Yeah. And so that's where we tried to look at this. And indeed, what we saw was that if you had more activity at baseline just before the stimulus was presented, like both in somatosensory cortex, but also in frontoparietal areas, you were more likely to detect it. Yeah. And that has been actually confirmed also by Andreas Kleinschmidt, and he has a lot of line of work on this. My take on this was, yes, this seems to be very important. But then I was, doing my PhD on coma and sleep, and my take on this was, okay, but what do these resting state fMRI fluctuation mean? And for me, the simplest question was also to look at, okay, what is there when you are unconscious versus when you're conscious, right? So there are two kind of ways to look at consciousness studies, two complementary ways. One is looking at the conscious state being there versus not, kind of a global approach or a level of consciousness, yeah. And then once you're conscious, then you can have a lot of different experiences, like of a phase, of a place. And then you can look at content-specific ones. Yeah, these are different questions. And so the PNS paper was on content-specific consciousness. And then I kind of extended more, moved to looking at how do these fluctuations change when you're conscious versus unconscious. So that's where we looked at that point, different levels of coma, but also anesthesia and sleep, and try to understand this better. Yeah. Right. And so seeing that when you're unconscious, when subjects report to be unconscious during anesthesia, then you have massively decreased connectivity. That's what you seem to see in most patients in coma as well. Yeah. Yeah. So, but that there was still some part that was there when you're unconscious, but there was more when you were actually reporting to have an experience there. So that was kind of my attack on this. But then, it was actually a little more complicated than just if the connectivity is decreased, then you're not there. Because say, for example, in sleep, I did a study in sleep where I found that it was not so decreased actually. It was more like modular, but it was not a massive decrease as I would expect, which might be related to something we found out before during this, during serial awakenings during sleep, finding that actually in non-REM sleep, you're conscious most of the time. Unlike what people are saying, REM sleep is considered as conscious sleep. In 95% of the cases, indeed, subjects report to be there. But even in non-REM sleep, 2/3 of the time, you're actually conscious dreaming, having an experience, even if you're disconnected. And so I see everything kind of pieces together progressively by again learning from not assuming that sleep is unconscious because your behavior is not there, but going further and really try to probe subjective experience as precisely as we can. If you ask in the morning, if people dream at night, they forgot most of their dreams. If you do serial awakenings or experience sampling more, kind of online as much as you can, you get much more sensitive for reports. Yeah.
Interesting. So maybe we'll just, I was going to talk about dreaming at the end, but this goes naturally right into dreaming. Let's talk a little bit more about your work on that. And you know, I saw a few papers and a couple of talks talking. So one thing that is striking, at least those people who don't follow the field, is your statement that even non-REM sleep, so non-REM, I always think of that as sort of, you know, eye movement seems to indicate conscious experiences, but apparently it doesn't, because during non-REM sleep, you say that we're dreaming at that point, and you got that information from asking people, you know, waking up people at various times.
Right.
So and that to me is new in that regard. Is there a difference, though? You're saying that whether you remember your dreams or not might have something to do with some neural signature in that regard, or remember that you had a dream versus the dream content?
So basically, when you ask people online just after they wake up if they were dreaming or not, they tell you in 2/3 of the cases during non-REM sleep that they were dreaming, and in 1/3 of the cases that they were unconscious, they were not there. And then in some cases, they were convinced they were dreaming, they don't remember of what.
Okay,
and in some cases, they could tell you the dreams. Yeah, the dreams in non-REM sleep are a little different than in REM sleep. It's typically less like of a full-fledged story, more thought-like, but there is also a lot of visual content and or self-content in there. But so it's a different type of experiences than in wakefulness, because you're disconnected from the world, you know, and there is like less self-reflection and some characteristics like this. But it's still a subjective experience. Like if we define consciousness as subjective experience, what it feels like to feel, you know, to have an experience of any kind, then actually dreaming qualifies, you know, as a subjective experience as well. But unresponsive, what is very important in there also is because it is a great way to try to dissociate consciousness from responsiveness, and also from a lot, say, if you compare wake to sleep, you compare apple and oranges. Neuromodulation is so different. There's so many things that change between wake and sleep per se. Right. But if you really look within sleep, within state paradigm, you can actually be more specific of trying to find what makes the difference between REM sleep conscious and REM sleep unconscious, or non-REM sleep conscious, non-REM sleep unconscious, find commonalities between them. And when you do that, you actually find that even if REM sleep and non-REM sleep are very different states from one another, the signature seems to be consistently that if you dream, you actually have less slow waves in the posterior cortex, versus you're unconscious, you have more slow waves in the posterior cortex. And that's very similar between the two. That within state paradigm, we think is very important, has not been done so much. Most of the studies before have actually conflated responsiveness and consciousness, looking at wake versus anesthesia, wake versus sleep. So that's why we actually think these are studies that have to be done also more, because they're very important for trying to diagnose, you know, the presence of experience in an unresponsive state. That's what you want to do in the clinic, in coma and all that. So
right. I mean, so it seems like there's and it also seems like there's two directions this can take. So it's sort of more like, you know, using these signatures to better diagnose these states, and just kind of using the signatures. But what about trying to understand, you know, what is it, like, for instance, the slow wave decreasing? I mean, what do you think is going on mechanistically? I mean, I don't know if anyone knows exactly.
You're totally right. The mechanistic understanding and the clinical implications go together. That's also, like, if you find that a certain part of the brain is much better predictor, like say the back compared to the front of the brain for the presence of experience, it can also teach you about you know, some why you need to find an explanation why, in a way. And that's also where the theory can come in and try to explain this. The potential explanation, and again, this with, so the finding about the importance of the posterior cortex for consciousness, we find this during these within state paradigms, this dissociation approach during sleep, but it also fits with lesion data in humans and also in animals. There were actually a few studies performed both in like looking at patients, the effect of surgery, for example, resecting most of the frontal lobe in the 40s. Also in some schizophrenia, we wouldn't do that anymore, but the data are there to kind of tell you what are the consequences of frontal lesions in human bilaterally, but also there were some studies in macaques and in cats showing that the animals had very complex behaviors, like you need to be conscious to have this kind of behaviors. That's the evidence we have in humans as well, even if the prefrontal cortex was removed. So there is lesion evidence that you don't need prefrontal cortex to be conscious. Yeah. Now, we don't know if it's involved in some contents of consciousness, but again, it's a different question, right? But it looks like the posterior cortex is actually, if you lesion the posterior cortex, you have much more consequences. Yes. Also predicting recovery from anoxic brain injury. If you compare models, taking the whole brain versus the back only and removing the front, you get a better accuracy if you keep the back only. So different lines of evidence suggest there's more research needed. Yeah. That lesions in the back have much more consequence again, also on who's going to be conscious and or recover from consciousness. Yeah. 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 Unconsciousness as well. So basically, these kind of lines of evidence from lesion and neuroimaging, and then also stimulation studies, these are very important to kind of also inform us mechanistically on what should be. It looks like not all the brain matters, not all the cortex is the same. So what are the differences? Yes. that could be explained? Yeah. Yeah. And so basically, as part of integrated information theory, we think that in the posterior cortex, there is a lot actually of interconnectivity, both specificity and interconnectivity, that makes that you have a lot of integrated information that can happen. It's not necessarily about the long range connections. We think it's more like this kind of pyramid of grids, topographical arrangement in the back of the cortex, where everything, there's a partial overlap in what there's a lot of commonalities, different pieces of information that can be specified on the same inputs. Basically, it's a long story, but shortly, it looks like the connectivity in the back has very good architecture to lead to high integrated information, and very specific as well. Yeah, a lot of different parts of the brain are actually specifying a lot of different pieces information. Yeah. Yeah, no, actually, there's you open up so many different directions of talking here. Okay. So, and actually this, when you're talking about the front and the back, the first, and let's talk about that a little bit. But before we talk about that, it just, and you also talk a little bit in your paper about layers. You mentioned with regard to dreaming, like the REM slow waves seem like they come from the supragranular layers of the visual cortex. And I'm trying to, and also there's work, we actually found some curious results in we're starting to do layer fMRI, looking at resting state, and we're trying to characterize the entire brain, and we find a clear differentiation between posterior and anterior parts of the brain, where it seems that posterior seems to have a different signature. We don't know exactly how to interpret it. It almost seems like it's sort of a feed forward, feedback, whereas the frontal cortex is more just feedback signature. And we get this pretty clearly looking at resting state power in each. We divide the brain into these columns, and then we look at the layer profile, and so it sort of suggests that there's some, we don't know exactly how to interpret, but there's a clear difference between front and back, which was more striking than we were anticipating. But also, maybe we should step back really quickly and just let's, we've been talking, we're already talking about consciousness in the front of the brain and the back of the brain, but I think it's important to define for everyone, what is the current, okay, so starting with consciousness, like what's the current working definition of consciousness? It's almost a taboo word in research, but as a neurologist, you have a very specific idea of what that is. Whereas, you might have neurophilosophers and things like that who think of it in a very different way. So what is
what is your working definition of consciousness?
The working definition, as I said, is subjective experience, or intuitively what disappears when you go into dreamless sleep.
Okay.
And I do think most people working on consciousness would agree on this definition as the goal of what we want to explain.
Yes.
And then there are different opinions in terms of how you can actually address this, like methods, you know?
Yes.
And one of the interesting development in the field too is actually this reflection about method in terms of the first studies have been mostly target detection task, like I did also in my PNS paper. But then now there is actually some recognition that this kind of report paradigm, target detection task relevant, are actually also associated with some confounds in the sense that you conflate consciousness with task performance. And so there is some evolution in the field. The same kind of thing you have for the level of consciousness, we try to dissociate experience from responsiveness. Well, in conscious humans, like, you know, no more typical humans, then actually you also need to dissociate experience from report, right? And so there is this kind of reflection in the field on trying to distill the neural correlates of consciousness from report or task performance.
Yes. Yes.
And so in that sense, it's an interesting evolution. And also, like, the ways people were assessing consciousness, there is more awareness now that this is the right term, that there is also what's called partial awareness. Even in you and I awake, there can be some kind of vague conscious experiences that still qualify as some conscious knowledge, because you can have, when you have a weak stimulus, you can have a perception that something was on the screen, but you don't know what.
Yeah.
And you can actually notice this with, you can quantify this quite precisely with some scales like perceptual awareness scale, where you directly ask subjects what they felt and you validate the scale on their experiences. They can even design their own scale, yeah? And when you do this, when you really try to validate the correspondence between subjective reports and the scale, you see that the subjects consistently say that it's graded, and there are some experiences where they had an impression something was there, but they don't know what. And this is important because a lot of studies that claim that there is unconscious processing were actually based on all or none. You know, did you see something or not, including blind sight in patients, you know?
Yeah.
And if you do look at perceptual awareness scale and you validate the correspondence between the reports and the experience in the subject, you actually see a very close correspondence between task performance and consciousness. So there is a lot of interesting debate now showing that, like, suggesting that if you actually directly ask subjects about their experience, there could be some unconscious processing, but it's much, much more limited than we would think. There's some debate in the field, but there's an interesting tag there, an interesting turn in that myth of 30 years that you can do everything unconsciously, you know? Actually, it's revisited because of these new methods. Another thing is a lot of studies actually chose post hoc the stimuli that were, you know, you give a range of stimulation, and I did the same too, you know? But we're learning that actually this is something that also has biases. It's called regression to the mean. And it's known in psychology for years, but we kind of somehow bypassed it because we were trying to figure out what to do. But if you do this, actually, there's a paper by Shanks showing that you also inflate unconscious processing. So, and it's very recent data, like from 2016 and debate, 2016, 17, it started to come up, you know, and also same for patients in blind side. So patients with V1 lesion. There is that kind of myth that actually these patients, I say myth because the evidence now, if you look at partial awareness, goes for the fact that it's not that these patients can actually do very complex tasks without feeling anything.
Right.
So they have some feeling of a stimulus moving on the screen. They don't know what it is, but there is a conscious experience going with task performance in these patients. There's even a study by Morten Overgaard, very well done, in one patient in blindside, where you ask them with binary, did you see something or not? Then you get a blindside. Like if they say, no, I didn't see, and then they can do it. But if you test for partial awareness, you actually see that when they are able to do the task, it's
Yeah.
because they had some kind of weak glimpse of an experience there. So this is also like very related to that dissociation between consciousness and responsiveness, and these graded, methods, graded awareness. There is a lot of interesting changes in the field.
Yeah. So I mean, that reminds me of right. I mean, if you give, I mean, even if you're sleeping, you can give auditory stimulus and see auditory cortex light up, but you can still remain sleeping, and it's sort of
right. But even during sleep, sometimes you perceive the tone, sometimes you don't. So we're actually doing a study now, trying to figure out, what are the responses during sleep when you heard the tone versus you don't.
Yeah. Yes. Yeah. That's cool. And that sort of touches on, I mean, right. I mean, it's generally thought that sort of like there's certain parts of the brain that are like, visual cortex or whatever that are not, are not conscious processes, but there might, as you're saying, it's definitely, sort of a feedback sort of process that goes both ways, and it might.
Right. I mean, we're learning on the way as we go. We're learning about this dissociation between consciousness and responsiveness, between experience and task, relevance. And then like with this, we're actually kind of maturing the field in terms of trying to really define consciousness as, like differentiating consciousness from cognitive functions. Now, if you look at now the data, there is good data that you can be conscious of something without doing something about it. So you can actually perceive, there is a dissociation between consciousness and cognitive function in that sense that everybody would accept. You don't need necessarily to do, I mean, most people, I think,
Yeah.
You don't need to do something when you perceive a stimulus. You don't, like, you can be in a meditation state where you're not doing things, or you're in dream, you're not really performing a task. But then the debate about unconscious processing, there seems to be some evidence for it, but more limited than what we thought. Yeah. But still, there is some dissociation between consciousness and the rest of what the brain does, cognitive functions. That and that is not only interesting conceptually, but also important for mechanisms. If you want to understand the mechanisms, you need to take these dissociations into account. Yeah.
Yeah. So I mean, okay. So I mean, it also makes me, I wasn't expecting to ask this, but if we flip it to people, the other side of the spectrum where people are highly conscious, they're perfectly normally functioning. It seems to me that, like, as you learn how to play like a musical instrument, for instance, you're extremely conscious of what you're doing. But then once you become an expert, there's a lot of things you do that are no longer sort of, you're conscious of in some sense. Is that, I mean, that's sort of flipping, the realm.
Well, there I would say the question is still open. We had even like that discussion with Christoph Koch yesterday. He was taking like basketball dribbling. And I was saying, how do you know, like, we should check partial awareness of that. Because if you're like when you're learning something, you're fully attending and conscious very vividly of it. But I just think this has to be revisited, which is interesting, kind of going back and at what has been done and see, okay, so how can I interpret the data? Did they look at binary judgments or no? Yeah. Did they do post-hoc selection of stimuli or no? And it's very important for coma patients to, because these behaviors that they have clinically, sometimes they are tracking. We don't really know what, or just fixating you, and we don't really know if that's actually in a human brain, consciousness or not. Again, the NCC in normals and in coma, it's actually very important to piece everything together. And I just think it's very exciting, first, that you need to have this kind of broad view of the NCC and the coma, clinical, the implications it had, but also that we are maturing as a field. There's a lot of things we're learning and a lot of things we can still do to try to piece the picture all together.
Yeah. Okay. Yeah. No, you're painting this picture that is, that it seems like you're coming at something. I mean, and also I just want to back up a little bit. In one of your papers, you mentioned, I mean, I'll get into IIT in a second, since that sort of, all this sort of hinges on that potentially, but it still seems that, and you talked about this a little bit, that, differentiating from just simply, consciousness isn't just simply stimulus response, where, you can have an algorithm detect, faces, whatever. And the algorithm detects faces, but there's no feeling of, the algorithm saying I detect a face in the context of the world, and I detect the face. It's just detect faces. And I thought that was interesting, because I thought, well, this is where people try to somehow put humans as separate from, in some sense, where you put yourself, you contextualize with enough layers that you suddenly are aware of. And this is sort of like maybe a slightly different take on consciousness in some sense, where humans are, aware of the context of themselves more, as opposed to just simply, stimulus response, even with complex responses. So, yeah.
Right. So you can show, like we've done that in, and I'm included to know in a few papers, that you could actually have the same function performed by a feed forward or just purely feed forward versus like integrated system.
Exactly.
If the feed forward was complicated enough. So in that sense, in theory, and also possibly in AI, you could have a dissociation where any function could be performed. Everybody kind of agrees that feedback seems to be very important for consciousness. Yeah. So it looks like in principle, you can have a lot of dissociation between the function being present and consciousness. In human brains, it might be less the case, because we think that integrated information is a way to pack many functions on a limited number of resources. Yep. So actually you can have some kind of general intelligence packed on, energy, efficient way, if you want. Yeah. That kind of evolutionary aspect. Now, the thing is, like every theory in physics is the same. There are some cases where you can test a theory and some cases where you cannot. Yep. So in humans, we know we're conscious. I have my experience. I can validate the scales of the reports on my experience. And then I can trust that actually the reports I'm getting from the third person perspective are good enough correspondence to my subjective experience, right? But in some cases like AI, we don't know. Like it's actually impossible to know. Yeah. It is a very similar, maybe with different ethical implications, but then the coma patient, how to infer consciousness in something else than me, right? So the best evidence we have for NCC, for neural correlates of consciousness, are in humans who can tell you, normal typical humans who can tell you, yes, I was perceiving something. Yes, I was conscious. No, I was not. Yes, I was perceiving a face. This is now. This is the best you can have. In animals, you can also get some reports, but there is some more difficulties with, getting something that is not task relevant. You cannot study dreams, but you can still some good data, get some good enough data, in the sense that if their brain and their behaviors are very similar to us, then our inference are fine. But the more you go, say, to octopus or AI and all that, the more difficult it is. And you cannot really test the theory on AI, but you could infer, say, imagine we have a theory that is well validated. That's what Julian Tononi and Christoph like to talk about. They talk about consciousness in AI. You cannot prove a theory right or wrong on this. This would be implications of the framework. Yeah.
Yes.
And so in that
framework,
sense, AI is interesting also to understand how brain computation work and all this. But to test the theory of consciousness, it's to me, it's a kind of a circular question.
Yeah.
How do you do that? Yeah.
Right. So that's a really good point. Yeah. And so let's just for the whole audience, let's maybe if you could summarize what the integrated information theory is. Just generally speaking.
So integrated information theory is an attempt to characterize the fundamental properties of conscious experience, and then to try to derive as rigorously as possible, using a mathematical framework, what would be the physical requirement for a neuronal substrate and or other substrate, if possibly, to support consciousness. So it's trying to make predictions about the physical substrate of consciousness. But in order to do so, the difference between consciousness and other objects of study is consciousness can only be seen from the inside. So you need to look at your experience and then try to find some fundamental properties from it, like what is properties that are always true. You could do that for memory, you could do that for attention too, but here we take consciousness. Okay, what are the fundamental properties of consciousness?
Yeah.
And if consciousness is like this, then the physical substrate should be able to support these properties. Otherwise, we don't have an explanation for it.
Right.
And so from it actually, so take, for example, integration and information, integrated information theory. So the theory predicts that your experience is very specific and has a lot of different parts that integrate together. So then the substrate of consciousness should actually also show a lot of differentiation and integration at the same time. So this is starting from my experience. It's actually like it is right now, a lot of different parts that integrate together. It's one, but it's differentiated, yeah?
Yeah.
And then you try to then predict, okay, like what we did with the TMS-EEG, the perturbational complexity index is saying then if experience is like this, the physical substrate of consciousness, when consciousness is there, should be like that.
Yes.
And so you find high differentiation when consciousness is there and low differentiation and integration at the same time when consciousness is low.
Yes.
So this is kind of, the approach is starting from consciousness as your object of study, defining properties, and then trying to find some measurements that are as principled and precise as possible, and predictions about also the kind of substrate that could do it.
Yeah. Okay, no, that was good. So I mean, is there any so for instance, so before we go back into talking about the parietal areas of the brain, but are there any areas where, I mean, some people have brought up the insular regions or the claustrum, or where this integration happens, or is it a general sort of the general architecture in the cortex at specific areas? Definitely this seems like the cerebellum is much more of a feed forward and
modular system.
Yeah.
So in the cortex is still an open question, really, to see where exactly would be. The theory predict that there should be a border to the substrate. So like it shouldn't be, and it kind of makes sense to intuitively, my consciousness is separate from yours. And then in the brain, there should be some border we can identify, like from the causal interactions, where like there should be a subset of neurons where integrated information is maximum.
Yes.
So there are like some proxies of integrated information. We're not calculating for fMRI signals. We're preparing a paper like that. And it seems that consistently posterior brain is involved, while the frontal cortex is less consistent. Now, it might depend on the kind of experiences you have, like say if you have the feeling of an effort, or like thought-like processes might be more mid-cingulate, but the theory predicts that there should be a principal way to figure this out using integrated information. There should be a maximum of integrated information within the cortex that we can identify. And it might change slightly depending on the task you perform. We actually even see that in the paper we're preparing, that it's changing slightly depending on what you're doing, if you're in resting state versus a task. But basically, there should be a physical explanation for why different parts of the brain, like a causal explanation for why different parts of the brain are involved or not. And the validation on theory versus the NCC is very important. On that note, it's also, I'm very glad of the efforts that are made right now to implement adversarial collaborations to contrast different theories of consciousness. I think this is a great progress. It's an initiative by the Templeton Foundation.
Okay.
So like there is two different projects going on, one in animal and one in humans, to try to contrast conflicting predictions from integrated information versus global workspace theory, for example. I think it's really great because one, we kind of understand each other better talking to each other, between the different theories. And then the second thing is really kind of contrasting on the same ground, like find some questions that really make a difference between different explanations. There is also some pilot project that is starting contrasting integrated information versus predictive processing, for example.
Okay.
I actually think predictive processing has a lot to say about the brain in general. And the free energy principle. I'm a big fan of Carl Friston. I talked a lot with him, but there might also be some part related to consciousness where it has more limitations because it's not really starting from consciousness itself. But then this kind of dialogue is really great because we can try to understand each other better, see what are the predictions differently, and then make progress like this, understand a little bit better also the type for experiments that make a difference. So I really like this as well. I think a progress in the field is the methods part, the distinction between consciousness and other processes. And then another big one is that dialogue between different theories to try to first understand, what is the scope and also the prediction of each one's being on consciousness and or the brain, and then kind of get some new ideas of experiments that can help to answer questions.
Yeah, no, that's great. I mean, that's actually, and it does seem like a very, I know also of Carl's, sort of work, and it seems that, right, some people could argue that they're different, but there's a lot of similarities, and it seems like it's more of a process of more refining, the questions, and more refining the
right. It's good to see like where we agree and then where the predictions differ, and then you can clarify actually,
right,
like kind of go further into how we think about things.
No, it's so right away. I mean, a lot of people might think, oh, well, you're looking for the areas that have the most integration in the brain. The first thought would be to do resting state and look at where the hubs are, the areas that are most correlated. But that's sort of a zeroth order sort of approximate. You have the anterior cingulate and posterior, the default mode network or whatever. But it's more than that. And
interestingly, in the paper we're doing now, it looks like the areas where our proxies of integrated information show the maximum have actually especially high local connectivity and not so much
interesting
the resting state network. So, there might be some interesting, again, the global workspace might be like more kind of long distance, but it's kind of complicated to know what other people would say, but there are some interesting new ways to see like what integrated information mean. And again, it's nice to kind of be able to talk between different frameworks to see what you mean by information, what do you mean by integration, what are you actually predicting. This is, I think, very important. And I do think there's a lot to look at in terms of consciousness and connectivity, not only at this kind of resting state network scale, but also, this kind of mesoscale, more at the grain where we find retinotopic mapping and all this kind of more content specific in a way,
Yes,
like,
yes. Yeah. I mean, there's so much to do, and especially with looking at the combination of EEG and fMRI as well. I mean, sort of what temporal and spatial scale does this occur? You're saying, that's intriguing that looking at as opposed to global connections. I mean, you might have a rich club that has just the right amount of local connections, and then you start getting into what is the right amount, and what really constitutes is it the number of connections? Is it the quality? Is it the information transfer rate? All kinds of things.
And it looks like more both connectivity and differentiation matter, right? Like if you look at EEG, we have that complexity index is a mix of both the differentiation of what the different parts of the network can specify, and then how integrated they are. So there is connectivity matters, but it's also while one of the predictions of IoT, we have a paper on the phenomenology of space, is that grid-like networks are actually especially good for high integrated information. And that might be related to all these basically spatial, being visual space, auditory space characteristics that are like a canvas on which a lot of features of our experience, like faces or, or objects, they plug in, So there is a lot of interesting work to be done in terms of explaining how different parts of the brain also are involved in the quality of experience and different aspects of the quality of experience.
That's
and I think that's what also is nice in the theoretical framework, that can look at both being conscious versus not and the quality of consciousness. If we can build some frameworks like this and test hypotheses about these aspects, to me, that's really also the way to go.
No, it seems that right. I mean, at least starting with that, and that's actually what I respected a lot about the people who are like Tononi and yourself and Carl, and trying to at least create a model that you can then test some predictions. And I like what you were saying just a second ago in terms of it's not just connectivity, it's not just connections. It's more you have to have appropriately modular and appropriately connected.
We call it a structure. So we say the quality of an experience can actually be characterized in terms of its structure. Like space is characterized by extendedness, a lot of different locations that piece together. It's a very specific structure versus the structure of like a face, like an invariant of a face. It's a very different kind of structure. And then you would actually infer that this should be a very different kind of network, you know,
Yes.
that
Yes.
would actually should also be structured in a particular way so that it can specify this, a correspondence between the quality of experience
Yeah.
and the connectivity of the network that underlies it. Yeah. So that's kind of like what we're trying to push in the theory work also is that where there's a part on space, part on invariance, trying to kind of really see how this maps to different parts of the cortex and then make predictions about this. Yeah.
Yeah. And right. I mean, so what do you think? I mean, so this brings me back to the idea of, Carl's idea, and many other people have had this, is sort of like the brain as a, all the brain does is try to model the world and predict, and so we can survive in some sense. And somehow in the process of doing that, in the process of evolving to do that, there's sort of a sense of modeling yourself within the world. And I'm wondering as to is conscious, is your conscious experience sort of an evolutionarily dictated, sort of necessary for survival trait, or is it an epiphenomena of just having a really sophisticated model of the world that's predictive?
So I think it's also, as we were discussing, an empirical question that can be revisited now even more efficiently now that we learned about, like, this kind of methods on how to match subjective experience to the measure you have of the third person measure you have. Yeah.
Yeah.
But the idea, the modeling work that has been done with Larissa Albantakis, for example, is suggesting that animates, that the small systems that have high integrated information, they're actually they can be more flexible.
Yep.
And if the task change, and if, as I mentioned, this kind of idea of more general intelligence, we don't know yet.
Yeah.
But in even this kind of epiphenomenon aspect, I'm kind of pushing the fact that I think that we have to accept that we actually don't really know, and we should check more because it's been a very important question, also with implications for how we assess patients with disorders of consciousness. And yeah, I mean, different theories would have different tacks on it. In IIT, we say that you don't necessarily need to predict to be conscious, and it can be dissociated. You can be conscious, and then you can use that for predicting, or not use it, or actually you can create something new. But and again, that's where a dialogue between the theories is very useful to see, what do you mean by predict? Is it predicting the time after, or is it that you learned, like through learning, you actually have some particular kind of connectivity that resonates with the world, what we call information matching? It's not necessarily predicting, but you have in your structure of your experience, it resonates with some features of the world, and it might be adaptive. So it's kind of a different tack on it. That's where the dialogue between theories is really actually very, and theorists and and others, it's actually useful to see, what do you mean? Where do we agree? Where do we differ?
And it's usually, a lot of it does seem like in the agreements and disagreements, and also just simply, even the disagreements, even in talking about, frontal cortex versus parietal, in terms of that part, it all seems like it comes down to still trying to, the disagreements are not actually it's more in defining, the problem. And it seems that people have different takes on what the question is, and what the context of, what the definition of consciousness and that sort of thing. It seems like the field is grappling with all of that in some sense.
So I think also, there's a part of the fact that what is special about the science of consciousness is we try to find an objective explanation for the subjective.
Yep.
And that for a very long time, also maybe with a history of behaviorism, looking at subjective reports, as data, or like subjective experience as the data you want to explain, was kind of uncomfortable for people. Now, with the success of the agenda of the research on consciousness, there's more confidence that actually that can be done. There are some more theories that really try to explicitly say, this is phenomenology we're trying to explain, and some clarification between the fact, report is a proxy, but it's not the same. Now, some limitations to it, like you can also be conscious without reporting directly. You can report after a few seconds. You can dissociate the two, right?
Yeah.
It's the maturity in terms of the fact that consciousness is different from other cognitive function. This is an object of study that is not only important to have ethically, but also, as I mentioned, there might be much more that about the functional role. It has to be elucidated more.
Yeah.
It's an object of study that is both feasible to study and also important to study. And so, and we learned a lot along the way. As we said, now it's nearly 20 years I'm in the business. I started when I was a medical student, and I saw a lot of change, but it's exciting because actually we see that there is a lot more dialogue into different point of views, clarifications being made, and a lot of things still to do. But I think there's a lot to be done, including, one of the things I'm also trying to push here in medicine is studying consciousness in patients also with focal lesions, looking at not only the effect of focal lesion, but diaschisis, like the network effect, and mapping that to both like this kind of agnosia, content-specific deficit in consciousness they have.
Yes.
So agnosia, like being aware versus unaware that you have a deficit. If you become blind because you lose an eye, you notice it.
Right.
If it's cortical blindness, if it's full blindness like Anton syndrome, you don't know you have a problem. This kind of content-specific disorders of consciousness is something. And also looking at dreaming versus function, like, experience versus function. What are the associations? How is it going together or not? The within state paradigms, there's a lot still to do about these.
Yeah.
Also looking at contents of consciousness, one thing that has been done a lot is kind of looking at stimuli that are at the limit of threshold of perception.
Yep.
But actually, it has to be integrated with also spontaneous experiences, or even, looking at supraliminal stimuli. So if I tell you content-specific change in consciousness is, you have an experience where a face is present versus not. Well, you can study this in like these kind of periliminal conditions, but you should also integrate it with the rest of the data showing, supraliminal stimuli. I experience a face versus not in that case. Plus, if you dream of a face, if you imagine of a face, all these have actually to be challenged to see what is the core mechanism that remains after you try to make all this dissociation.
Well, that's cool. Right. I mean, it just, to me, it opens up sort of the idea that, so you're, just the whole, I mean, there's many, many states of consciousness. And I really thought, your point of agnosia was interesting because, I mean, you can have attention deficits, you can have lesions and not, there's classic, obviously, neurology experiments where people are, asked to draw a clock and they just draw, half of it and they're not even aware that they do that. And I can also imagine that even, I just wonder, even as far back as Phineas Gage, when he had that rod through his head, was he fully aware of the fact that his behavior was altered to some degree?
What is interesting is some brain lesions cause anosognosia and some don't.
Yeah.
The classic distinction is Broca, aphasia. Patients are really, really aware. They know what they want to say. They cannot say that. They're super frustrated about it. Wernicke aphasia, it's more like a comprehension deficit. They have no clue that they have a problem. So some cortical lesions do it, some cortical lesions don't. There's a lot more to understand about about what difference it makes. And for us, it's also another complementary way to try to understand which areas are involved in consciousness versus more output areas.
That's really cool. That's a good level.
So there's a lot to do about neurology and consciousness, and it has been done a little, but there's much more to do. Also, epilepsy and consciousness. There are just a few groups that look at that. There's we're doing some work in generalized tonic-clonic seizures, looking at intracranial recordings, seeing when you lose consciousness completely. Again, about connectivity, there's more activity within the brain. What is the difference between, more activity in response to conscious experience versus more activity during seizures? Like what are pushing to the limit this idea of cortical firing and consciousness? How can it go together or separately? So, there's a lot of interesting questions you can get from the clinic as well.
Yeah, so much to do. I realize we're coming up on sort of our time. I mean, there's so many other things to talk about, perhaps another time.
But just one thing, Peter, about the layers. I didn't answer your question about the layers. So what we see in REM sleep compared to wake is actually that you have some slow waves in the primary cortices. So, but then not in the rest of the brain, in the superficial layers in that case, yeah.
Okay.
But it's basically, and then in non-REM sleep, you have slow waves all over the place.
Yeah.
But what this suggests is actually there is a mechanism to disconnect you from the environment in the primary sensory cortices during REM sleep, which is interesting because we still don't have an explanation why you actually are disconnected from the world during sleep. In terms of layers, it's still an open debate of which layers actually matter. Do the whole cortical column matter versus some other parts there? I think there's a lot more to do about that. But I think your finding about the front versus back architecture is super relevant. It would be very interesting to kind of correlate that with some new consciousness experiments. Yeah.
Yeah, no, it does seem that, right. I mean, the layer work is very preliminary, but I think that's another direction that fMRI can take. Unfortunately, it takes, it might be able to be done at 3 Tesla, but right now at 7 Tesla, we're working on that. And we're trying to actually find good paradigms as well to just help tease out, the meanings of, it's cortical architecture. We still don't even completely understand what, if it's homogeneous, in the sense of feed forward and feedback, but it seems like there's some patterns that we can use to interpret.
Yeah, one interesting thing would be to calculate, a proxy of integrated information and see if actually that feed forward and feedback versus feedback only, like what's the best match if there is any components to it. Yeah, I think that would be very interesting.
That would be cool. All right, I'll have to talk to you more about that.
Yeah. Story to be continued, but I think that would be really cool.
Yeah, and okay, but before we finish, one other quick thing. I also, as far as sleep, very quickly. It just occurred to me, I remember seeing a paper on, sort of decoding dreams and using fMRI to do that, but they were actually looking at a very different, in my opinion, at least from my own subjective experience, a very different phase of sleep. And that's sort of like I guess it's called a hypnagogic state, where just as you're falling asleep, you have this sort of release and you suddenly get these, it's almost like hallucinations. It's almost like, where you see very vivid, it's sort of dreamlike before you then fall into your deeper states. And it seems that that's obviously another potentially interesting time period to study sort of the mechanism of maybe release that, conscious release that sort of allows dreams to occur in some sense. I don't know.
Right. What is very interesting comparing dreams to wake is that there are some particular features of experience that differ. So Ben Baird was looking recently at 140 subjects who were waking up, at night and looking at the difference between wake and then REM and non-REM sleep. And some features are interesting. For example, you seem to have decrease in metacognition, but also, self is not so much different, but in non-REM and REM, it's much less goal-directed. It's much more present-centered, and also in the falling asleep period, we're trying another study now, going to the descent of falling asleep. There have been some report compared to wake that you have a decreased sense of self, unlike say during REM, and then that you have a decrease of sense of control too. Again, we're trying to confirm this in the data, but this is also an interesting way to look at the NCC in spontaneous experiences, to see, okay, if I have more or less self-awareness and lack of self-experience in one state, how does it correlate with brain activity and all this?
Yeah. Okay.
So yeah, it is. I think it's an open question to really characterize better these states, but there is a richness in phenomenology and how also it differs from one another, and what's common in very different neuromodulation states. That is a great challenge for the NCC as well. That's
great.
More to come, but I also think that these kind of spontaneous experiences, they were understudied compared to the task-based, NCC, and they have. It's really important to try to integrate them and see, when you try to really challenge your NCC, what remains, what is general versus what was more particular to a particular condition or task.
Yes. Yeah. You can imagine designing experiments where you have this, these array of but also it's very challenging to sort of assess the state in a sort of continuous fashion, so you can objectively get a measure of what's going on
Right. So what we do is waking them up every,
Yeah, that's miserable.
minutes.
Oh my gosh.
Or also like in wakefulness, so it's experience sampling. Yeah.
Okay.
It's like taking the subjective experience as data.
Yeah.
And
yeah.
I think you've done in an fMRI paper recently as well.
Yep. Yeah. My postdoc, Javier Gonzalez Castillo, we're trying to just do time series. We're looking at resting state, and he really cares about, the conscious correlates of resting state. There's a lot of other things in it, but we're trying to figure out how do you get a person's state without disrupting their state. So it's tricky. It's at least in that sense. I mean, with sleep, you can actually you could imagine, resting state where people are awake, but then you interrupt them at various times, and you try to look at exactly what's going on ahead of time. But we'll see how that goes. But the field keeps on evolving, and I think
it's really an exciting time for consciousness research too. As I said, we're learning a lot from the methods. We see that there is something particular also to consciousness versus function. There are some dissociations in different ways, but also a lot to revisit about how we actually measure things, how specific the markers we have are for consciousness versus other processes.
Yeah, I completely agree. I mean,
then with also that urgent need, ethically in the clinic, in ICU, that's why the Curing Coma campaign is also rising right now. Is because we see that we know some patients are unresponsive and they are still conscious. We don't know about the other ones. It's very urgent to try to improve the state of the science. And then say, like for TMS-EEG, we're trying to really make that tool also more portable. But in general, there's an awareness of the fact that, there is so much ethical implication, and also so much more we can do about trying to find some therapies for these patients. So that's also pushing the field forward.
Yeah. And right. I mean, the clinical applications are almost immediate in that regard. So that's actually really nice. And that's what helps to push the field as well. So this is great. This is a great conversation. It's funny. I always have my notes sort of in a linear fashion, but then jumping around, because it's so interdigitated sort of field with the methods. So like I said,
it was a great pleasure. Thank you so much for having me.
Yeah, well, thank you, and maybe at some point in time we can have you back or whatever. But thank you very much for spending time to talk about this and giving us a sense that there's so much more to do, and there's so much going on in terms of this. So, all right, well, thank you.
Thank you so much. Have a great day.
You too.
Neurosalience is brought to you by the Organization for Human Brain Mapping and is produced by Anastasia Brovkin, Ekaterina Dobrikova, Katie Moran, Niels Mullert, Kevin Seatek, and me, Rachel Stickland.